Have you ever wondered how the universe began and where it's headed? From the Big Bang to distant galaxies, black holes, and mysterious exoplanets, this 10-part cosmic journey will take you across time and space. If you love exploring the wonders of the cosmos, make sure to hit subscribe and like to join our journey beyond the stars. Part 1. The beginning of everything. Every star you see in the night sky is a memory. When you look upward, you're not seeing the present, you're looking into the past, across billions of years of cosmic history. Tonight, we begin the journey through the greatest story ever told, the story of the universe itself. Long before Earth, before the sun, before even the galaxies, there was only silence. Then, 13.8 billion years ago, a great beginning burst forth, what we now call the Big Bang. But it was not an explosion in space, it was the sudden creation of space and time itself. In the first instant, the universe was smaller than an atom, unimaginably hot and dense. Within seconds, it expanded at a speed faster than light, an event called cosmic inflation. Space stretched, carrying with it the seeds of everything that would ever exist. As the young universe cooled, protons and neutrons formed. Then, hydrogen and helium, the simplest elements. For hundreds of thousands of years, the cosmos was a glowing fog of particles, too hot for light to escape. But as it cooled further, atoms formed, and the universe became transparent. For the first time, light could travel freely, and the echo of that moment still surrounds us today as the cosmic microwave background. The early universe was not perfectly smooth. Tiny ripples of density left from inflation caused some regions to gather matter more strongly than others. Over millions of years, gravity pulled these regions together, forming great clouds of gas. These clouds collapsed, igniting the first stars. These were not stars like the ones we see now. They were giants, hundreds of times more massive than our sun, burning furiously, living fast, and dying young. Within their cores, nuclear fusion created heavier elements: carbon, oxygen, iron, the building blocks of life. When these first stars exploded as supernovae, they seeded the universe with the material that would someday form planets, oceans, and living beings. From the darkness, the first galaxies were born. Spirals, ellipticals, and irregular swarms of stars gathered together, each one glowing like an island of light in an ocean of night. Over billions of years, they formed the great cosmic web, vast filaments of galaxies stretching across the universe, separated by enormous voids. In these galaxies, new generations of stars formed, each one building upon the ashes of the ones before. And in one small corner of one galaxy, around one ordinary star, a planet would eventually form, a world of oceans and continents where life would gaze upward and ask how it all began. But for now, in this first part of our story, the universe was still young, filled with the fire of newborn stars, a place of chaos and beauty, growing larger and more mysterious with every passing moment. And so begins our journey, from the birth of time itself, across the ages of galaxies, black holes, and worlds beyond imagination. Part 2. The Dance of Galaxies. The young universe was no longer silent. Stars blazed across the dark, galaxies swirled into being, and gravity began its endless work of shaping the cosmos. If Part 1 was the dawn, then this part is the story of structure, the dance of galaxies across the sea of space. Galaxies are not evenly scattered like grains of sand. Instead, they form a vast cosmic web, with filaments stretching for hundreds of millions of light years. These filaments thread across the universe like glowing veins, connecting clusters of galaxies together. Between them lie the cosmic voids, immense regions almost empty, like great dark caverns of space. Within these clusters, galaxies interact. Some spiral gracefully, their arms curling outward like cosmic whirlpools. Others are elliptical, giant glowing ovals filled with older stars. Some are irregular, torn apart by collisions or shaped by gravitational tides. Galaxies are not static islands. They move, collide, and merge, shaping each other in endless dances that last billions of years. When galaxies collide, it is not like cars crashing on a highway. The space between stars is so vast that they almost never hit directly. Instead, their gravity pulls at one another, distorting shapes, triggering waves of star formation, and sometimes creating entirely new galaxies from the chaos. These collisions are slow ballets, unfolding over hundreds of millions of years. One day, even our own Milky Way galaxy will collide with its neighbor, the Andromeda Galaxy. The two are rushing toward each other at more than 100 kilometers per second. In about 4 billion years, they will meet. From Earth, the sky will become extraordinary, Andromeda growing larger and larger until it stretches across the heavens, merging with our own galaxy into a new giant, sometimes called Milkomeda. But long before that distant future, galaxies have already been shaping the universe for billions of years. At their centers lie mysteries. Nearly every galaxy appears to have a supermassive black hole at its heart, millions or even billions of times more massive than the Sun. These black holes anchor galaxies, influencing their growth and sometimes erupting in spectacular displays of energy. From a distance, galaxies seem eternal, glittering islands of light. Yet within them, stars are constantly born and constantly dying. Giant clouds of hydrogen collapse into new suns, while giant stars explode into supernovae, enriching space with heavy elements. This cycle of birth and death continues endlessly, seeding the cosmos with the material for planets, oceans, and perhaps even life. The universe is vast, but it is not empty. Every point of light in the night sky, every galaxy in the deep field of a telescope is part of this grand cosmic dance, a choreography written by gravity, time, and light itself. And somewhere in that dance, a small spiral galaxy on the edge of a filament, with a quiet star and a fragile blue planet, will one day begin to wonder what it means to be part of this story. Part 3. The Mystery of Black Holes. Among the most haunting objects in the universe are black holes, regions where gravity is so strong that nothing, not even light, can escape. They are invisible, but their influence is everywhere. They bend space, warp time, and serve as cosmic engines of both destruction and creation. The idea of black holes began as theory. In the early 20th century, Einstein's equations of general relativity predicted such objects could exist. At first, many scientists doubted them. How could nature allow a place where physics itself breaks down? Yet over the decades, evidence grew too strong to ignore. There are different kinds of black holes. Some are formed when massive stars exhaust their fuel and collapse under their own weight. These are stellar mass black holes, only a few times more massive than the Sun, but packed into an unimaginably tiny space. Others are the supermassive black holes at the centers of galaxies, millions or even billions times more massive. How they form is still one of astronomy's greatest mysteries. What we do know is that black holes are not simply vacuum cleaners, sucking everything nearby. A planet or star could orbit a black hole safely if it kept its distance, just as Earth orbits the Sun. But cross the event horizon, the invisible boundary where escape is impossible, and you are gone forever. The most bizarre aspect is what happens near this horizon. Time itself slows down. To a distant observer, anything falling in seems to freeze at the edge, stretched and dimmed by gravity. But for the object falling in, time flows normally until it reaches the point of no return. What lies beyond remains unknowable. In 2019, humanity caught its first true glimpse of a black hole. The Event Horizon Telescope combined data from observatories around the globe to produce an image of the shadow of a supermassive black hole in the galaxy M87. It looked like a glowing orange ring, warped light surrounding a dark heart. For the first time, what was once only theory became visible. Black holes also fuel some of the brightest objects in the cosmos. As matter swirls into them, it forms accretion disks, hot, glowing rings of gas spiraling inward. Some black holes shoot out enormous jets of energy, stretching for thousands of light years, visible across the universe. In a strange twist, these destroyers help shape galaxies, regulate star formation, and spread heavy elements into space. There are even more exotic possibilities. Some scientists suggest that black holes could connect to other regions of space-time, wormholes, theoretical bridges that might link distant parts of the universe. Others wonder whether black holes could play a role in the birth of new universes. These ideas remain speculative, but they remind us how much we still don't know. What is certain is this: black holes are not simply cosmic voids. They are fundamental to the universe, sculpting galaxies, challenging our understanding of physics, and hinting at deeper truths. They stand at the edge of knowledge, daring us to look closer. And yet, as terrifying as they seem, without them, the universe might not look the way it does today. They're part of the cosmic balance, the shadows that allow light to shine. Part 4. The Birth and Death of Stars. Every star in the night sky tells a story, not just of shining light, but of a journey billions of years long. Stars are born, live vibrant lives, and eventually die, sometimes quietly, sometimes in spectacular explosions that reshape the universe itself. Stars begin in the cold, dark clouds of gas and dust that drift between galaxies. Inside these vast nebulae, gravity slowly gathers matter together. Denser regions collapse, growing hotter and brighter, until at last a spark ignites. Nuclear fusion begins, and a star is born. Fusion is the heart of a star's power. Hydrogen atoms fuse into helium, releasing enormous amounts of energy. That energy pushes outward, balancing the crushing force of gravity pulling inward. This balance allows stars like our Sun to shine steadily for billions of years. Without fusion, the universe would be cold and dark. But stars are not eternal. Their fate depends on their size. Small stars, like red dwarfs, burn slowly and can live for trillions of years. They are the quiet keepers of the cosmos, glowing gently across time. Medium stars, like the Sun, eventually run out of hydrogen fuel. They swell into red giants, shedding their outer layers into space, leaving behind a small, dense core, a white dwarf that slowly cools. The most massive stars face a far more dramatic ending. When their fuel is gone, they collapse violently, triggering a supernova, one of the most powerful explosions in the universe. For a brief moment, a single star can outshine an entire galaxy. These explosions scatter heavy elements, iron, gold, carbon, across space. Every atom in your body, heavier than hydrogen and helium, was forged in a star and released in such a death. You are, quite literally, made of stardust. Sometimes, the collapse after a supernova is so extreme that a star becomes a neutron star, a city-sized sphere of matter so dense that a teaspoon would weigh billions of tons. Some neutron stars spin rapidly, sending out beams of radiation we detect as pulsars. Others, even heavier, collapse further into the ultimate mystery, a black hole. Star birth and star death are not just isolated events. They are part of a cosmic cycle. The gas and dust released by dying stars enrich nebulae, providing the raw materials for new stars, new planets, and perhaps new life. The universe recycles itself endlessly, building worlds from the ashes of the old. When you look up at the night sky, every point of light is not just a star, it is a story in progress. Some may already have died, their light only now reaching us after traveling across unimaginable distances. Others are still being born in hidden clouds of gas we cannot yet see. The heavens are alive, always changing, always renewing. The stars remind us of two truths. Nothing lasts forever, and yet nothing is truly lost. Their deaths create the possibility of new beginnings. Out there in the dark, the universe is always writing its next chapter in fire and light. Part 5. The Search for Exoplanets. For most of human history, the question, "Are we alone?" was pure speculation. We knew of only one planet with life, Earth. But in the past few decades, a revolution has unfolded. Astronomers have discovered thousands of exoplanets, worlds orbiting stars beyond our Sun. And with each discovery, the possibility of other Earth-like planets grows stronger. The first confirmed exoplanet around a Sun-like star was found in 1995, 51 Pegasi b, a giant world orbiting so close to its star that its year lasts just 4 Earth days. This discovery stunned scientists. It didn't look like anything in our own solar system, and it showed that planetary systems could be stranger than we had ever imagined. Since then, technology has transformed our ability to detect these distant worlds. The Kepler Space Telescope, launched in 2009, monitored the brightness of over 150,000 stars, looking for tiny dips in light when a planet crossed in front, a method called the transit method. Kepler alone found over 2,600 confirmed planets, from scorching hot giants to small rocky worlds not much bigger than Earth. Today, new observatories like TESS, or Transiting Exoplanet Survey Satellite, and James Webb Space Telescope, or JWST, are taking the search further. JWST, with its powerful infrared vision, can analyze the atmospheres of exoplanets, searching for chemical fingerprints such as water vapor, carbon dioxide, and perhaps, one day, signs of biology. One of the most exciting discoveries has been the TRAPPIST-1 system, just 40 light-years away. It hosts 7 Earth-sized planets, 3 of which lie in the habitable zone, the region where liquid water could exist. Imagine standing on the surface of one world and seeing 6 others hanging in the sky, close enough to appear larger than our moon does from Earth. Not all exoplanets are Earth-like. Some are hot Jupiters, massive gas giants hugging their stars. Others are super-Earths, rocky planets larger than Earth but smaller than Neptune. There are worlds of endless storms, scorched surfaces of molten rock, and frozen orbs locked in eternal darkness. The diversity is staggering. Yet somewhere among these thousands, perhaps millions of planets, there may be one truly like our own. Oceans, clouds, continents, and the possibility of life. For now, we cannot visit these worlds. They're too far, separated by light years of empty space. But with every discovery, we are mapping the possibilities. Each exoplanet is a hint that the universe is not just stars and galaxies. It is also a universe of worlds, some familiar, some utterly alien. As you look up at the stars tonight, remember, around many of them, unseen planets are circling, silent and distant. Some may be barren, some may be beautiful, and perhaps on one of them, someone might be asking the same question we do. Are we alone? Part 6. The Expanding Universe. In the early 20th century, most scientists believed the universe was static, eternal, unchanging, infinite. But in 1929, astronomer Edwin Hubble made a discovery that would rewrite our understanding of everything. Galaxies are moving away from us, and the farther they are, the faster they recede. The universe itself is expanding. This revelation meant that the cosmos had a beginning. If everything is spreading out now, then in the past, it must have been closer together. Extrapolated backward, this leads to the idea of the Big Bang, the moment, about 13.8 billion years ago, when the universe burst into existence from a hot, dense state. At first, the Big Bang was controversial. Many doubted it, preferring the idea of a steady, eternal universe. But in the 1960s, scientists discovered the cosmic microwave background, a faint glow of radiation spread across the entire sky. This ancient light is the afterglow of the Big Bang, a direct fingerprint of the universe's fiery birth. Expansion did not stop there. In the late 1990s, another shocking discovery shook cosmology. The universe isn't just expanding, it's accelerating. Distant supernova observations showed galaxies moving apart faster and faster, as if some unseen force is pushing them. Scientists call it dark energy, but what it really is remains one of the greatest mysteries of modern science. If dark energy continues, the universe will grow emptier over time. Galaxies will drift farther apart until their light no longer reaches one another. Stars will burn out, and only black holes and cold remnants will remain. Far in the future, even those black holes may evaporate, leaving a universe of silence and darkness. But the story is not all bleak. The fact that we live in this moment, when galaxies still shine, when stars are still being born, when life exists, makes our era uniquely precious. We live at a cosmic dawn, able to look back to the birth of time and forward to its distant faith. And though expansion may seem abstract, you can see it in the night sky. Every galaxy you glimpse through a telescope is on its own path outward, carried by the stretching of space itself. The cosmos is not static, it is alive, restless, and moving. The expanding universe is a reminder that nothing stays the same forever. From the tiniest atoms to the largest structures, everything changes. And in that change lies both mystery and beauty, the eternal unfolding of a story bigger than all of us. Part 7. Dark Matter and the Invisible Universe. When we look at the stars and galaxies, it's easy to believe we're seeing the whole picture of the universe. But astonishingly, everything we can observe, stars, planets, gas, and dust, makes up less than 5% of the cosmos. The rest is hidden, invisible, yet its presence shapes everything. One of the great mysteries is dark matter. It does not shine, absorb, or reflect light, making it invisible to telescopes. Yet we know it must exist because of its gravity. In the 1930s, astronomer Fritz Zwicky noticed that galaxies in a cluster were moving too fast to be held together by visible matter alone. Something unseen was providing the extra pull. Decades later, Vera Rubin confirmed this on a galactic scale. When she measured how stars rotated around the center of galaxies, she expected stars on the edges to move more slowly, like planets in our solar system. Instead, they moved just as fast as stars near the center, as if an enormous halo of invisible mass was holding the galaxy together. That invisible mass is what we now call dark matter. It outweighs ordinary matter by 5 to 1. Without it, galaxies would fly apart and the universe would look nothing like it does today. Dark matter acts as the scaffolding of the cosmos, pulling matter together and shaping the grand structures we see across billions of light years. What is dark matter made of? That remains unknown. Some theories suggest it could be exotic particles beyond anything we've ever detected. Others imagine faint, undetectable objects or even entirely new laws of physics. Despite decades of experiments deep underground and in space, dark matter has never been directly observed. Even more mysterious is dark energy, the force driving the universe's accelerating expansion. Together, dark matter and dark energy make up 95% of everything. Yet we understand almost nothing about them. It is as though we are staring at a puzzle where nearly all the pieces are missing. Still, the mystery itself is thrilling. It means the universe is not yet fully revealed. Behind the stars we see lies a hidden realm, one that holds the secrets to why galaxies exist, why the universe evolves the way it does, and perhaps why we are here. Every time you gaze into the night sky, remember, most of what surrounds us is invisible. But invisibility does not mean unimportance. In fact, it is the unseen that holds everything together. Part 8. The Fate of the Universe. If the universe had a beginning, it must also have an ending. For centuries, humans have wondered not only where we come from, but also where we are going. Thanks to modern cosmology, we now have glimpses of possible futures, though the final answer is still uncertain. The universe is expanding, driven by the mysterious force of dark energy. But what will happen billions or trillions of years from now depends on how that expansion behaves. Scientists consider several scenarios. One possibility is the Big Freeze. If dark energy remains constant, the universe will keep expanding forever. Galaxies will drift farther apart until their light can no longer reach each other. Stars will burn out and new ones will stop forming. Over unimaginable timescales, the cosmos will grow dark, cold, and empty. Black holes will evaporate, and all that remains will be a thin haze of particles in eternal night. Another scenario is the Big Crunch. If gravity someday overcomes dark energy, the expansion could slow and reverse. Galaxies would fall back together, stars and planets collapsing into a final fiery implosion. The universe would end as it began, in heat and density, perhaps even giving rise to a new Big Bang. Then there is the most dramatic idea, the Big Rip. If dark energy grows stronger with time, expansion will accelerate so violently that galaxies, stars, planets, and eventually even atoms will be torn apart. The very fabric of space-time would unravel in a cosmic catastrophe. There are even more exotic possibilities. Some physicists wonder if our universe might tunnel into a new state of physics, collapsing in a sudden transformation. Others suggest that new universes may constantly butt off from our own in a grand multiverse, making our cosmos just one chapter in an endless book. For now, we cannot know which fate awaits. But what we do know is that we live in a very special era, one where stars still shine, galaxies still glow, and life exists. In the grand timeline of the cosmos, this moment is fleeting, but it is ours. When you look up at the night sky, you are not just seeing the past, you are also glimpsing the universe's future. The stars remind us that even in endings, there are beginnings. The cosmos has been reborn before, and perhaps it will be reborn again. The fate of the universe may be uncertain, but one truth remains. Existence itself is a miracle. That we can ask these questions at all is proof that the universe has, at least for now, given us the gift of wonder. Part 9. Human Exploration of Space. For as long as we have gazed at the stars, we have dreamed of reaching them. Human exploration of space is one of the greatest stories of our species, a tale of courage, ingenuity, and the eternal desire to go beyond the horizon. The journey began in the mid-20th century, during the space race. In 1957, the Soviet Union launched Sputnik 1, the first artificial satellite into orbit. Just 4 years later, in 1961, Yuri Gagarin became the first human to travel into space, circling Earth in a single orbit. His words, "I see Earth, it is so beautiful," captured the awe of a new age. The United States soon followed, setting its sights on the moon. In 1969, Apollo 11 achieved the impossible. Neil Armstrong and Buzz Aldrin walked on the lunar surface, leaving footprints that still remain today. For the first time, humanity had left its home world and set foot on another. Since then, space exploration has expanded beyond national rivalry. Space stations like Mir and later the International Space Station, ISS, became laboratories in orbit where astronauts from many countries live and work together. The ISS has been continuously inhabited since the year 2000, making it a symbol of human cooperation in the vastness of space. Robotic missions have gone even farther. The Voyager probes, launched in 1977, are now traveling through interstellar space, carrying golden records with sounds and images of Earth. Rovers like Curiosity and Perseverance explore Mars, searching for signs of ancient life. Space telescopes like Hubble and James Webb peer deep into the cosmos, showing us galaxies billions of light years away. And the journey is far from over. Humans are preparing to return to the moon through NASA's Artemis program, building a gateway that may serve as a stepping stone to Mars. Private companies are pushing the boundaries of reusable rockets, dreaming of colonies on other planets. Space exploration is not just about discovery. It also gives us perspective. From orbit, astronauts describe the overview effect, the profound realization of Earth's fragility when seen as a small blue sphere against the darkness. Borders vanish, conflicts fade, and only one truth remains. We are all passengers on this same tiny world. One day, we may walk on Mars, sail the icy oceans of Europa, or even voyage to other stars. Each step outward begins with a dream, the same dream that has guided us since the first humans looked up at the night sky. We explore because it is part of who we are, to understand, to seek, to go beyond. The universe is vast, but so is our curiosity. Part 10. The Future of Space and Humanity. The universe stretches farther than the eye can see, filled with galaxies, stars, and mysteries yet to be discovered. But humanity's story is just beginning. In the coming centuries, we may leave Earth behind, spreading across the solar system and perhaps even beyond. Colonies on the Moon and Mars may become reality. Scientists are already studying terraforming, ways to create habitable conditions on other worlds. Spacecraft powered by nuclear or fusion engines could make interstellar travel feasible, allowing humans to visit distant star systems in decades rather than millennia. Beyond exploration, space holds the promise of knowledge and survival. Our planet faces natural and human-made risks. By expanding into space, we reduce the chance that a single catastrophe could end humanity. In a sense, the stars are not just objects of wonder, they are insurance for life itself. But the future is not only practical, it is also poetic. Imagine generations of humans looking up at alien suns, composing art under unfamiliar skies, and discovering life elsewhere. Perhaps one day we will meet intelligent beings who gaze at their night skies and wonder just as we do. Technology will grow, enabling us to harness the energy of entire stars through Dyson spheres, or even manipulate the very fabric of space-time. Black holes and wormholes, once purely theoretical, could become bridges across the cosmos. And yet, for all our ambition, the universe will remain infinitely mysterious. As we move outward, humanity will carry something unique: the ability to reflect, to dream, to ask questions. The universe is immense, but so is our imagination. Every discovery will bring new questions, and every journey will bring awe. So, as this story ends, remember, the universe is not just out there. It is within us, in our curiosity, our courage, and our desire to understand. From the first stars to the distant future, from black holes to unknown worlds, the cosmos is a story, and we are part of it. Look up tonight. Every twinkle is a whisper from the past, a promise of the future, and an invitation to wonder. Humanity's journey through space has only just begun, and the story of the universe continues, written in light and shadow across the vast, eternal night. This story will take you on a journey through the wonders of the universe, from the birth of stars to black holes to the mysteries of distant galaxies. If you enjoy listening, don't forget to like this video and subscribe for more cosmic stories. Part 1. The Silent Beginning. Far above us, beyond the clouds, beyond even the thin blue line of our atmosphere, stretches the endless sea of space. It looks silent, almost empty, when we raise our eyes to the night sky. But in reality, the universe is alive, full of energy, light, and stories written across billions of years. Every star you see is not just a shining point of light. It is a world, a history, a time machine glowing in the darkness. Astronomers believe our universe began nearly 13.8 billion years ago with the Big Bang. Not an explosion in the ordinary sense, but the sudden expansion of space itself. Imagine the entire cosmos compressed into something smaller than a grain of sand, and then, in less than a heartbeat, swelling outward faster than light. From this moment, space, time, and the very laws of physics were born. In the first seconds, the universe was unimaginably hot and dense. Protons and neutrons began to form, the building blocks of atoms. Within minutes, hydrogen and helium appeared, the simplest elements, destined to become the fuel of stars. For hundreds of thousands of years, the universe was filled with a glowing plasma, a fog of particles and light so thick that nothing could travel freely. It was not until about 380,000 years later that the fog cleared, allowing light to escape for the first time. That ancient light, known today as the cosmic microwave background, still travels across the universe, a faint whisper from the dawn of time. Billions of years passed. Slowly, under the pull of gravity, gas gathered into great clouds. Within these clouds, the first stars were born. They ignited like cosmic lanterns, pushing back the darkness of the early universe. These stars were massive, far larger than our sun, and they lived fast, burning their fuel in only a few million years before exploding as brilliant supernovae. Their explosions seeded the cosmos with heavier elements, carbon, oxygen, iron, the ingredients of planets, oceans, and even life itself. And so, the universe began to take shape. Galaxies spun into being, clusters of stars bound together by gravity, forming magnificent spirals and giant elliptical forms. Among these galaxies, billions upon billions of stars were born, each one a possible sun for a future world. Our own Milky Way, a graceful spiral stretching more than 100,000 light-years across, became one of these homes for countless stars and mysteries. Deep inside one of its arms, about 4.6 billion years ago, a small star lit up, our Sun. Around it, a disk of dust and gas swirled, slowly clumping together into planets. Among them, one tiny blue world formed, covered in oceans and skies, destined to become home to us. But before Earth, before life, before humanity, there was only silence, stars, and the vast story of space itself. Part 2. The Birth of Stars. The story of stars is the story of creation itself. If you're enjoying this journey through the universe, remember to like this video and subscribe so you don't miss the next chapter of Cosmic Wonders. Far across the galaxy, in vast and silent regions, lie immense clouds of gas and dust. To the human eye, they might look like empty black patches against the stars, but in truth, they are nurseries, places where stars are born. Astronomers call them nebulae. Within these clouds, gravity is at work, pulling hydrogen atoms closer and closer together. As the gas clumps, the temperature begins to rise. The cloud darkens, tightens, and slowly begins to glow. It can take millions of years for a star to form, but once the process begins, it is unstoppable. At the heart of the collapsing cloud, a core grows denser and hotter, until finally, at around 15 million degrees Celsius, something extraordinary happens: nuclear fusion. Hydrogen atoms fuse into helium, releasing enormous amounts of energy. A star is born, blazing into the darkness. The first breath of a star is like the first cry of a newborn child. For the first time, the surrounding darkness is pushed away, and light fills the region. If you were nearby, though no human ever could be, you would see waves of radiation sweeping across the nebula, sculpting its edges into pillars and arcs of glowing gas. What looks to us through telescopes like delicate cosmic art is actually the raw, powerful breath of newborn stars. The life of a star depends on its size. Small stars, like red dwarfs, burn their fuel slowly, glowing faintly for trillions of years, far longer than the universe itself has existed so far. Stars like our Sun live more balanced lives, shining steadily for billions of years before gently expanding into red giants and casting off their outer layers. Massive stars, though, are impatient. They burn with ferocious brightness, consuming their hydrogen in just a few million years. Their deaths are spectacular supernova explosions, some so bright they outshine entire galaxies for days. These explosions are not just endings, they are beginnings. When a star dies, it scatters the heavy elements it created in its core into space. Carbon, oxygen, nitrogen, iron, even gold and silver. Every atom of calcium in your bones, every molecule of oxygen in your lungs was forged in the heart of a star that lived and died long before the sun was born. Carl Sagan once said, "We are made of star stuff," and it is not poetry, it is scientific truth. Star death also leaves behind strange remnants. Some massive stars collapse into neutron stars, incredibly dense objects where a teaspoon of matter would weigh billions of tons. Others go further, collapsing into black holes, places where gravity is so strong that not even light can escape. And yet, as some stars die, others are born. The cycle never ends. Across the Milky Way, thousands of stars ignite each year, while countless others fade away. It is a cosmic rhythm, the heartbeat of the universe, continuing without pause for billions of years. When you look up at the night sky and see those tiny points of light, you are witnessing this cycle in motion. Some of those stars are still young, barely beginning their lives. Others are ancient, burning through the last of their fuel. And some may already be gone, their light only now reaching us across the emptiness of space, carrying with it a story billions of years old. Part 3. The Dance of Galaxies. The universe is not still. If you're enjoying this cosmic journey, don't forget to like the video and subscribe. More space stories await you among the stars. When you look up on a clear night, you see the Milky Way stretching across the sky like a river of light. What you are seeing is just one spiral arm of our galaxy, home to more than 200 billion stars. But the Milky Way is not alone. It is part of an enormous cosmic community with billions of galaxies scattered across the observable universe. Each one is a magnificent city of stars, dust, and mysterious dark matter, bound together by gravity. Galaxies come in many shapes. Some are elegant spirals, their arms winding gracefully like a whirlpool of light. Others are massive ellipticals, shaped like glowing spheres filled with old stars. Still others are irregular, twisted, and chaotic, sculpted by collisions and cosmic accidents. And yes, galaxies do collide. When two galaxies meet, they don't crash like cars on a highway. The vast distances between stars mean that direct collisions are rare. Instead, their gravity pulls and stretches them, twisting their shapes into long tidal tails of stars and gas. Over millions of years, the galaxies merge, creating a new, larger galaxy. It is a slow, silent dance, choreographed by gravity, performed on a stage billions of light years wide. Our own Milky Way is part of this cosmic ballet. In about 4 billion years, it will collide with the Andromeda Galaxy, our nearest large neighbor. Already, astronomers can see Andromeda approaching at 110 kilometers per second. When the two galaxies meet, their stars will swirl into new patterns, their black holes may merge, and a new galaxy will be born, sometimes called Milkomeda. To anyone living on Earth, then, the night sky will look unimaginably beautiful. Andromeda filling the heavens, its stars mingling with our own. Galaxies don't just dance with each other. They gather into families called clusters, held together by invisible webs of dark matter. Some clusters contain thousands of galaxies, all orbiting a common center of mass. Even these clusters are not the end of the story. They themselves gather into superclusters, forming a vast cosmic web that stretches across the universe. When mapped, this web looks like a giant sponge or neural network with filaments of galaxies threading through immense voids of emptiness. One of the humbling truths is that galaxies are not eternal. Over billions of years, star formation slows down. Gas is used up, and new stars no longer ignite. Galaxies grow old, fading into quiet collections of red and dying stars. Yet even in their silence, they remain monuments of the universe's story, relics of creation still glowing faintly in the dark. So the next time you see the hazy band of the Milky Way above you, remember that it is not a static picture. It is moving, evolving, part of an endless cosmic dance. Every star in the sky is taking part in that choreography, moving with gravity's rhythm, step by step over eons of time. Part 4. The Mysteries of Black Holes. The deeper we look into the universe, the more it challenges our imagination. If this story keeps you fascinated, don't forget to like the video and subscribe. Many more cosmic mysteries are waiting to be told. Black holes are among the most mysterious and powerful phenomenon in existence. They begin with death, the death of a massive star. When such a star has burned all its fuel, its core collapses under the crushing force of gravity. If the core is heavy enough, no force in the universe can stop the collapse. Matter is squeezed into a point of infinite density, a singularity, hidden behind a boundary we call the event horizon. Beyond that horizon, nothing, not even light, can escape. At first, the idea of black holes seemed like science fiction. Even Albert Einstein, whose equations predicted them, doubted they could exist in reality. Yet over the decades, astronomers have gathered overwhelming evidence. We have watched stars orbiting invisible points, pulled by gravity so strong it could only be a black hole. We have detected the ripples of space-time, gravitational waves, created when two black holes collide. And in 2019, the impossible became visible. The Event Horizon Telescope gave us the first image of a black hole's shadow glowing orange against the darkness. Black holes come in different sizes. Some are just a few times the mass of our Sun, the remnants of collapsed stars. Others, called supermassive black holes, sit at the centers of galaxies, weighing millions or even billions of solar masses. Our own galaxy, the Milky Way, has one, Sagittarius A*, a giant 4 million times the mass of the Sun, hidden behind clouds of dust 26,000 light-years away. What happens inside a black hole is one of the greatest unsolved mysteries of physics. General relativity, Einstein's theory of gravity, says that everything is crushed into the singularity. Quantum mechanics, the science of the very small, says that information can never truly be destroyed. Reconciling these two truths is one of the deepest puzzles in science. Even stranger, black holes are not entirely black. In the 1970s, Stephen Hawking showed that black holes can slowly lose energy through a faint glow now called Hawking radiation. Over unimaginable timescales, trillions upon trillions of years, even the largest black holes will eventually evaporate, leaving behind nothing but whispers of radiation. But perhaps the most breathtaking idea of all is that black holes might not be an end, but a doorway. Some theories suggest that what falls into a black hole could emerge elsewhere in the universe, or even in another universe entirely. These remain speculations, but they remind us how much we still do not know and how vast the mysteries remain. To gaze into the heart of a black hole is to look into nature's most perfect paradox, a place where time stops, space folds, and the rules of physics themselves seem to break. Yet black holes are not monsters destroying the universe. In fact, they may be essential to its structure. Astronomers believe supermassive black holes help galaxies form, shaping the very stars and worlds around them. The same objects that consume light might also give birth to the cosmic order we see around us. Part 5. The Search for Other Worlds. The night sky is full of stars, but how many of them have worlds like ours? If you're enjoying this journey through the cosmos, don't forget to like this video and subscribe. More stories of space are waiting for you. For most of human history, Earth was the only known planet. The sun, the moon, and the stars seemed eternal and unreachable. Even the planets of our own solar system, Mercury, Venus, Mars, Jupiter, and Saturn, were mysterious points of light slowly wandering across the heavens. But everything changed in the last few decades when astronomers discovered something extraordinary. Planets are everywhere. These planets beyond our solar system are called exoplanets. The first confirmed detection came in 1992 when two tiny worlds were found orbiting a pulsar, the remnant of a dead star. A few years later, in 1995, astronomers announced a giant planet orbiting a sun-like star called 51 Pegasi. It was a milestone that opened a floodgate. Since then, with the help of powerful telescopes like Kepler and TESS, we have discovered thousands of exoplanets, over 5,000 confirmed so far, with more being added every month. Some are gas giants larger than Jupiter, orbiting so close to their stars that their years last only a few days. Others are frozen worlds, orbiting faint red dwarfs. Some may even be rocky planets, similar in size and temperature to Earth. Astronomers have a special interest in planets within the so-called habitable zone, the region around the star where liquid water could exist. Water is essential for life as we know it, and finding it elsewhere would be a step toward answering one of humanity's oldest questions. Are we alone? Already, candidates have appeared. Planets like Kepler 452b, sometimes called Earth's cousin, orbit their stars at just the right distance for water. The TRAPPIST-1 system, with 7 rocky planets, has drawn special attention. 3 of those worlds lie within the habitable zone of their star. Though we don't yet know if they have oceans or atmospheres, they remind us that Earth may not be unique. Technology is now advancing to let us study these worlds in greater detail. The James Webb Space Telescope, launched in 2021, can analyze the atmospheres of exoplanets by capturing starlight as it filters through them. By studying the light, scientists can look for chemical fingerprints, signs of oxygen, methane, or even water vapor. One day, these observations might reveal not just habitable planets, but inhabited ones. The idea that we may not be alone in the universe is as old as humanity itself. Every culture has looked up at the stars and wondered if there are others out there. For now, we have only questions, but each exoplanet discovery brings us closer to answers. Think of this. Every star you see in the night sky could have planets around it. Worlds of oceans, deserts, mountains, and storms. Some may be lifeless. Others may hold strange forms of life, plants, creatures, or even civilizations looking back at the stars as we do. The universe is vast, and our search has only just begun. Part 6. The Secrets of the Solar System. We often dream of distant galaxies and mysterious exoplanets, but the truth is our own solar system is filled with wonders beyond imagination. If you enjoy this cosmic journey, remember to like this video and subscribe. More stories are on their way. The solar system is a family of worlds, bound together by the gravity of our sun. At the center burns the star that gives us life, a steady furnace that has shone for 4.6 billion years and will continue for billions more. Around it orbit 8 planets, more than 200 moons, countless asteroids, comets, and icy bodies. Each one tells its own story. Closest to the sun lies Mercury, a small rocky world where daytime temperatures can melt lead and nights plunge into freezing cold. Next comes Venus, Earth twin in size, but not in spirit. Wrapped in thick clouds of carbon dioxide, it is the hottest planet in the solar system, with surface temperatures hotter than an oven and pressures that could crush a submarine. Then, Earth, the blue planet, the only world we know with life. Oceans, forests, skies, and all of us spinning quietly in the darkness. Our moon orbits nearby, guiding tides and illuminating the night. Without it, Earth's tilt might wobble wildly, and life could have struggled to find stability. Beyond Earth lies Mars, the red planet. Dry and cold today, but ancient riverbeds tell us it once had flowing water. Some scientists believe that billions of years ago, Mars might have been more Earth-like, with lakes and perhaps even life. Robotic explorers like Curiosity and Perseverance are searching for clues, while humans dream of one day walking its rust-colored plains. Further out, the gas giants reign. Jupiter, the largest planet, is a swirling giant of storms, home to the Great Red Spot, a hurricane 3 times the size of Earth that has raged for centuries. Its moons are miniature worlds themselves. Europa, with an icy crust hiding a vast ocean beneath. Ganymede, the largest moon in the solar system. Io, covered in erupting volcanoes. Each could hold secrets of life or geology unlike anything we've seen. Saturn follows, adorned with its breathtaking rings of ice and rock. Though thin and delicate, the rings stretch across hundreds of thousands of kilometers, making Saturn one of the most beautiful sights in the sky. Its moon Titan has thick orange clouds and lakes of liquid methane, while Enceladus shoots geysers of water into space, a possible sign of an ocean beneath. Beyond Saturn lies Uranus, tilted on its side, rolling around the sun like a spinning ball. Its pale blue color comes from methane in its atmosphere. Neptune, the farthest giant, is a deep azure world of fierce winds and storms. And far beyond them all, the Kuiper Belt, a region of icy bodies, comets, and dwarf planets like Pluto, Eris, and Haumea. The solar system does not end there. The Oort cloud, a vast shell of icy fragments, may surround us at a distance so great it takes light a year to cross. From time to time, one of these icy bodies falls inward, becoming the comets we see streaking across our skies. Every world in the solar system is unique, and together they form a cosmic neighborhood still full of mysteries. Though we have sent probes to many planets, much remains unexplored. Beneath the icy crusts of Europa and Enceladus, in the methane lakes of Titan, or deep under Mars's soil, life may yet be hiding. And even if Earth is alone in its life, the solar system reminds us of the fragile balance that made our world possible, a balance that could have easily been different. Part 7. Time, Light, and the Edge of the Universe. If you're enjoying this story, don't forget to like this video and subscribe. More cosmic journeys are waiting. When you look at the stars, you are not seeing them as they are now, but as they were long ago. Light takes time to travel, and the universe is vast. The light from the moon takes just over 1 second to reach us. Sunlight takes about 8 minutes to reach us. The light from the nearest star, Proxima Centauri, takes over 4 years. And when we look at the Andromeda Galaxy, we're seeing it as it was more than 2 million years ago. Every glance into the night sky is a look back in time. The farthest light we can see comes from the edge of the observable universe, the cosmic microwave background, the faint glow left over from the Big Bang nearly 13.8 billion years ago. This ancient radiation is like a baby picture of the cosmos, showing us the universe as it was when it was just 380,000 years old. It surrounds us in every direction, whispering of beginnings too distant to truly imagine. But light is not just a messenger of time. It is also bound by the deepest laws of physics. According to Einstein's theory of relativity, nothing can travel faster than light. It sets the ultimate speed limit of the universe. But relativity also tells us something stranger. The faster you move, the slower time flows for you. This is not theory alone. Astronauts on the International Space Station, moving at 28,000 kilometers per hour, age slightly more slowly than people on Earth. The difference is tiny, but real. In the extreme environment near a black hole, time itself stretches almost to a stop. To an outside observer, a falling object appears to freeze at the event horizon, never truly crossing. Inside, however, the object continues, though what happens next remains hidden behind the veil of relativity. The expansion of the universe also bends our sense of time and distance. Galaxies are not simply moving through space. Space itself is stretching, carrying them farther away. Some galaxies are already beyond our reach. Their light, stretched into infrared by cosmic expansion, will never arrive. The observable universe is about 93 billion light-years across, but beyond it may lie infinite space, forever beyond our sight. This raises profound questions. Is there an edge to the universe? If space goes on forever, what does infinity truly mean? Or if the universe is finite, what lies beyond it? These are questions no telescope yet can answer. But every observation, every photon of light captured by our instruments brings us closer. In a way, the universe is a great time machine. The stars above us show not just beauty, but history. When you look at the sky, you are witnessing a story billions of years old, still traveling toward your eyes at the speed of light. And perhaps the greatest mystery is this. If we're looking back in time every time we gaze at the stars, what stories from the future might the universe be waiting to tell? Part 8. The Future of the Universe. If you've enjoyed the journey so far, remember to like this video and subscribe. Your support helps keep these cosmic stories alive. The universe has a beginning, but does it have an end? This question haunts astronomers and philosophers alike, and while no one can know with certainty, science has given us several possible futures. Right now, we know the universe is expanding. Galaxies are rushing away from one another as space itself stretches. For much of the 20th century, scientists debated whether this expansion might someday slow, perhaps even reverse, leading to a big crunch, a collapse where all matter falls back together, returning to a hot, dense state like the Big Bang in reverse. But in the late 1990s, astronomers discovered something unexpected. By studying distant supernovae, they found that the expansion of the universe is not slowing down, it's accelerating. Some mysterious force, which we call dark energy, is pushing galaxies apart faster and faster. If this continues, the universe may face a heat death. Over trillions of years, stars will burn out, galaxies will fade, and only black holes will remain. Even they will eventually evaporate through Hawking radiation, leaving behind a dark, cold, empty cosmos. Time itself would stretch endlessly, but nothing would remain to witness it. There are other possibilities. Some theories suggest a big rip. If dark energy grows stronger with time, it could eventually tear galaxies, stars, planets, and even atoms apart. The very fabric of space-time could unravel, ending the universe in a final, violent moment. Another idea is the Big Bounce. Perhaps the universe expands until it cannot stretch further, then collapses back only to explode outward again in another Big Bang. If true, we might be living in just one cycle of an eternal cosmic heartbeat, where universes rise and fall forever. Beyond these grand endings lies one more mystery: the multiverse. Some cosmologists suggest our universe may be just one bubble among countless others. If so, new universes could be born, even as ours fades. What lies beyond our cosmic horizon may be stranger than we can imagine. Worlds with different laws of physics, different stars, different possibilities. And yet, despite all these predictions, we live in a fleeting moment of cosmic brightness. Stars still shine, galaxies still glow, life has emerged, at least here, to gaze upward and ask questions. For now, the universe is alive with energy, and our time within it is more precious because it is temporary. Perhaps the most beautiful truth is this: no matter how the universe ends, every moment we live is part of its story. We are made of stardust, born in the fires of long-dead stars, and when we look to the future, we are really looking into the mirror of our own fate. The cosmos is not only out there, it is within us. Its future is our future. Part 9. The Search for Other Worlds. If you're enjoying this journey through the universe, don't forget to like this video and subscribe. More cosmic stories are coming to help you dream among the stars. For centuries, humans looked at the night sky and wondered if other worlds like Earth might exist. For a long time, it was only imagination. But in the last few decades, that dream became reality. Astronomers discovered that planets around other stars, exoplanets, are not rare at all. In fact, they're everywhere. The first confirmed exoplanet was discovered in 1992, orbiting a pulsar, the dense dead remnant of a star. A strange place for planets to exist. But in 1995, a new discovery changed everything: a giant planet orbiting a sun-like star. Since then, we have confirmed more than 5,000 exoplanets, and the number keeps growing. Some of these worlds are hot Jupiters, massive gas giants that orbit so close to their stars they are scorched at thousands of degrees. Others are frozen giants, far from warmth. But among them are rocky planets, some roughly the size of Earth, lying in the habitable zone, not too hot, not too cold, where liquid water could exist. One of the famous discoveries is the TRAPPIST-1 system, with 7 Earth-sized planets orbiting a small, cool star just 40 light-years away. At least 3 of those planets lie in the habitable zone. Imagine a sky where other worlds are so close that they appear larger than our moon, entire planets hanging above the horizon. With telescopes like the James Webb Telescope, we are now beginning to study the atmospheres of these distant planets. By analyzing the light that passes through an exoplanet's atmosphere as it crosses its star, scientists can detect gases like water vapor, carbon dioxide, and even methane, possible fingerprints of life. The ultimate question is, are we alone? Life on Earth began surprisingly quickly after the planet formed, suggesting that life might also emerge easily elsewhere. Yet, we have not found direct evidence. The silence of the universe is sometimes called the Fermi paradox. If life is common, why haven't we seen signs of it? Some answers may lie on nearby worlds. Mars, Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, may all hold clues. Frozen oceans beneath thick ice could hide microbes or even something more complex. Each discovery brings us closer to knowing. If we find even the simplest life elsewhere, it will mean Earth is not unique. It will mean the universe is filled with possibilities. If we find nothing, it will make our own existence even more extraordinary, a fragile flame in the vast dark. Either way, the search for other worlds is also a search for ourselves, for in discovering whether we are alone, we discover what it means to exist. Part 10: Humanity's Journey Beyond Earth. If you've enjoyed traveling through the universe with us, don't forget to like this video and subscribe. More cosmic stories will continue to guide you among the stars. For thousands of years, humans dreamed of touching the heavens. We watched the moon, the planets, and the distant stars, imagining what might lie beyond. But only in the 20th century did those dreams begin to take shape. It started with rockets, simple, powerful machines that could break free of Earth's grip. The first successful rockets were humble, small, and experimental, but they paved the way for something far greater. In 1957, the Soviet Union launched Sputnik 1, the first artificial satellite to orbit Earth. A tiny metal sphere, no larger than a beach ball, changed the world forever. Humanity had entered space. Just 4 years later, Yuri Gagarin became the first human to orbit the planet. He circled Earth in a spacecraft called Vostok 1, witnessing the world from above, a fragile blue marble suspended in the blackness. His famous words, "I see Earth, it is beautiful," captured the awe and humility of the first human perspective beyond our world. The space race soon took us further. The Apollo program landed humans on the moon in 1969. Neil Armstrong and Buzz Aldrin walked on the lunar surface, leaving footprints that might last millions of years. For the first time, humans had set foot on another world, gazing back at Earth, a glowing orb of oceans and clouds in a sky of endless black. Since then, humanity's presence in space has grown steadily. Space stations orbit our planet. Astronauts live for months at a time, conducting experiments that would be impossible on Earth. Robots explore Mars, Titan, and distant asteroids, sending back images that astound and inspire. We are now on the cusp of a new era. Private companies plan to send humans to Mars. Scientists are designing ships that could travel to other star systems within our lifetimes, or perhaps our grandchildren's lifetimes. The dream of walking among the stars is no longer fantasy. It is a challenge we are beginning to meet. But space is not just a place to explore physically, it is also a mirror. When we see Earth from orbit, we understand its fragility and beauty. When we imagine the universe beyond, we confront our smallness and our potential. Every mission, every telescope, every discovery reminds us that the cosmos is vast, mysterious, and waiting. Humanity's journey beyond Earth is just beginning. One day, our descendants may live among the stars, stepping onto planets orbiting other suns, witnessing alien skies, and perhaps finding life in forms we cannot yet imagine. For now, we can dream, explore with our minds, and let the stars guide us. The universe is immense, but it has welcomed us to begin our journey. And as long as we look up, we will continue to reach outward, toward the infinite. What if I told you that the most mysterious traveler in our solar system wasn't a spacecraft, but a rock from another star? This is the story of Oumuamua, the strange interstellar object that passed through our neighborhood in 2017, and how it changed the way we look at the universe forever. Subscribe and like if you're ready to journey into the unknown depths of space. Part 1. The Visitor from the Stars. The night skies have always held secrets, but in 2017, astronomers spotted something that would ignite both scientific curiosity and wild speculation across the world. A telescope in Hawaii detected a faint dot, moving far too quickly and on a trajectory that made no sense. Unlike comets or asteroids that loop around the sun in familiar orbits, this object was flying straight through, a cosmic passerby that entered our solar system from deep interstellar space. They named it Oumuamua, a Hawaiian word meaning a messenger from afar, arriving first. It was the perfect name, poetic, mysterious, and a reminder that this wasn't just another asteroid. It was the first confirmed interstellar object humanity had ever observed. Scientists scrambled to study it before it disappeared forever. What they found made the mystery even greater. Oumuamua didn't look or act like anything we had seen before. It had no tail like a comet, yet it reflected sunlight strangely. Its shape, based on brightness variations, seemed elongated, perhaps cigar-like or even pancake-flat. Some estimates suggested it was hundreds of meters long, tumbling through space. But the most puzzling thing wasn't its shape, it was its motion. As it traveled away from the sun, Oumuamua accelerated slightly, as though something was pushing it. Normally, comets do this when sunlight warms their ice and creates jets of gas that act like tiny rocket engines. But telescopes saw no coma, no tail, no visible outgassing. It was as if an invisible hand was nudging it along. This led to one of the most controversial questions in modern astronomy. Was Oumuamua just a natural rock, or could it be something else? Part 2. A mystery in motion. As Oumuamua sped away from the sun, astronomers had only weeks to gather data before it slipped beyond the reach of even our most powerful telescopes. Each observation made the mystery deeper. Its brightness fluctuated dramatically, suggesting it was tumbling end over end, unlike the steady rotation of most asteroids. That strange light curve hinted at a body with an extreme shape, long and thin like a cosmic needle, or wide and flat like a celestial pancake. But the real enigma was the acceleration. Tiny changes in speed had been measured with precision, and they couldn't be explained by gravity alone. With no visible jets or trail, the usual comet explanation seemed unlikely. The object was moving as though something unseen was propelling it. This strange behavior divided the scientific community. Some argued that we were simply witnessing a never-before-seen kind of natural object, perhaps a fragment of a larger body, chipped away during the violent formation of another star system. Others suggested exotic ideas, a hydrogen iceberg that evaporated invisibly, or a sheet of frozen nitrogen reflecting sunlight in odd ways. Each hypothesis tried to account for the odd shape, the tumbling, and the unexplained boost in speed. And then came the boldest suggestion of all. In 2018, Harvard astronomer Avi Loeb proposed that perhaps, just perhaps, Oumuamua was artificial. His paper raised eyebrows and fueled headlines across the globe. What if this was a fragment of alien technology, a discarded light sail, or a probe built by another civilization passing through our system by chance? The scientific world responded with fierce debate. Many dismissed the idea, urging caution and sticking to natural explanations. After all, extraordinary claims require extraordinary evidence. But the very fact that serious scientists were even entertaining the possibility gave the story of Oumuamua a cultural weight far beyond astronomy journals. News outlets called it the alien asteroid. Sci-fi writers and dreamers saw it as proof that humanity might not be alone. And the public? They were captivated. For a brief moment, the world seemed united in wonder, looking up and asking the same question. What exactly just passed through our cosmic backyard? Yet, while theories flew, the object itself slipped farther and farther away. By early 2018, Oumuamua was too faint to track, leaving behind only questions. We may never see it again, but its fleeting visit had already changed science forever, forcing us to ask new questions about what lies beyond the borders of our star. Part 3. Preparing for the next visitor. Oumuamua slipped quietly out of view, leaving astronomers with a sense of both wonder and frustration. They had just glimpsed the first confirmed interstellar object, and yet it was gone before they could uncover its true nature. For scientists, that fleeting encounter wasn't an ending, it was a beginning. If one messenger from the stars had passed through, surely more would follow. In fact, it didn't take long. In 2019, a second interstellar traveler was detected, Comet Borisov. Unlike Oumuamua, Borisov looked and behaved more like a typical comet, with a bright tail of gas and dust trailing behind. Its appearance confirmed what many had suspected. Interstellar visitors weren't rare miracles, but part of the natural rhythm of our galaxy. We simply hadn't had the tools to spot them before. The discovery of Borisov energized astronomers. If two interstellar objects appeared within just a couple of years, there must be many more slipping through our solar system all the time, unnoticed. With better telescopes, we could catch them earlier and maybe even chase them down. That dream is no longer just science fiction. Space agencies and scientists have begun planning missions to intercept the next interstellar visitor. One such idea is the Comet Interceptor mission by the European Space Agency, scheduled for launch later this decade. It will wait in orbit until a suitable target, perhaps an interstellar comet, is discovered, and then sprint out to meet it, capturing data before it vanishes back into the dark. Other proposals are even bolder. Some scientists have suggested pre-positioning spacecraft in deep space, ready to accelerate toward any unusual object detected entering the solar system. Others dream of building powerful solar sails or nuclear-propelled craft that could match the speed of interstellar travelers, giving us a chance to see them up close for the first time. The stakes are high. Each visitor carries secrets about the environments in which it formed, long ago in star systems far beyond our own. Their chemistry, their shapes, even their strange behaviors could reveal how planets and comets form across the galaxy. And though most scientists remain cautious, there is always the possibility that one of these travelers might not be entirely natural. Oumuamua taught us that the universe can surprise us at any moment. Now astronomers wait with sharpened tools, ready for the next knock on our cosmic door. Part 4. Messages from other worlds. When we look at an interstellar object like Oumuamua or Comet Borisov, we aren't just looking at a rock or a chunk of ice. We are peering into the history of another star system, frozen into a fragment and flung across the galaxy. Each visitor is a time capsule, carrying within it clues about how distant worlds were born. Most of the objects that form in a star system never become planets. Instead, billions of icy and rocky fragments are scattered outward during the turbulent early years of a system's life. Some are ejected entirely, sat adrift between the stars. These lonely wanderers drift for millions, even billions of years before they chance upon another star. And sometimes that star is our sun. Borisov, for example, was rich in carbon and cyanide gas, chemicals also found in comets within our own solar system. That similarity tells us that the chemistry that shaped Earth and the other planets is not unique. The building blocks of life are spread widely through the galaxy. Oumuamua, on the other hand, seemed entirely different. Its lack of a tail, its strange shape, and its puzzling acceleration challenged our understanding of what these fragments could be. Was it a shard of frozen nitrogen chipped off a Pluto-like world around another star? Or perhaps a thin sheet of ice and dust, fragile and unlike anything we've cataloged before? Each theory pushed scientists to think beyond the boundaries of what we had previously imagined. The excitement comes from this. Every interstellar object offers us a chance to test whether our solar system is typical or unusual. Are Earth's conditions and the chemistry that gave rise to life common across the galaxy or rare? If comets from other systems carry the same molecules we see here, then perhaps life's recipe is written everywhere among the stars. And so the study of interstellar wanderers is not just about rocks in space. It is about origins. It is about searching for the universal patterns that may one day answer one of humanity's oldest questions. Are we alone? Each passing visitor is like a whisper from another world, a fleeting chance to hear the stories written in starlight. But whispers fade quickly. To truly learn, we must be ready to listen more carefully next time. Part 5. Eyes on the Sky. For centuries, humanity searched the skies with little more than glass lenses and patience. Today, our tools are far more powerful, yet still, Oumuamua almost escaped our notice. It was discovered by chance in October 2017 by the Pan-STARRS telescope in Hawaii, and within a matter of weeks, it was already fading from view. That brief encounter reminded astronomers of an uncomfortable truth. Our current systems for spotting interstellar visitors are barely adequate. But that is about to change. In the coming years, a new generation of telescopes will transform our ability to scan the heavens. At the forefront is the Vera C. Rubin Observatory in Chile, expected to begin operation soon. Its wide-field camera will be the most powerful survey instrument ever built, capable of imaging the entire visible sky every few nights. With its unprecedented sensitivity, astronomers estimate it could detect dozens, perhaps even hundreds of interstellar objects over its lifetime. Imagine that! Instead of rare surprises once a decade, we may soon find a steady stream of wanderers passing through our solar system. Each discovery will give us more opportunities to study these messengers in detail, to compare them, and to learn how diverse the galaxy's building blocks truly are. Other observatories will play their part too. The James Webb Space Telescope, already peering into the distant universe, can also turn its golden mirrors toward nearer mysteries. With its ability to detect faint chemical signatures, Webb could analyze the gases and surfaces of interstellar objects, helping us decode their composition from millions of kilometers away. And this is just the beginning. The combination of survey telescopes on Earth and space-based observatories orbiting high above our planet will create a network of eyes watching for the next anomaly, the next strange traveler whose path cuts through our neighborhood. With each new discovery, we edge closer to answers. What kinds of materials are common across the galaxy? Do all star systems produce comets and asteroids like ours? Or are there exotic forms we've yet to imagine? Could some fragments even carry clues about life's potential in other corners of the Milky Way? The sky is vast, and the visitors are fleeting. But for the first time in history, we are preparing not just to glimpse them in passing, but to catch them in detail, before they vanish forever. Part 6. Chasing the interstellar visitors. Spotting an interstellar visitor from Earth is thrilling, but for scientists, observation alone is never enough. They want to touch, to sample, to bring back pieces of the unknown. The challenge, however, is speed. By the time we notice an object like Oumuamua, it's already racing away at tens of kilometers per second. To intercept it, we need spacecraft that are fast, flexible, and ready to launch at a moment's notice. One of the most promising projects on the horizon is the Comet Interceptor, a European Space Agency mission scheduled for launch in the late 2020s. The plan is brilliant in its simplicity. Instead of chasing after a visitor once it's discovered, the spacecraft will wait in space, stationed at a gravitational balance point known as L2. When a suitable target, a pristine comet or perhaps even another interstellar traveler, is spotted, Comet Interceptor will dash toward it, deploying smaller probes to study the object up close. But for true interstellar objects, some scientists argue we need even more ambitious concepts. The Project Lyra study, for example, explored ways to catch up with Oumuamua itself, even though it's already far beyond Neptune. Their ideas included using powerful solar sails, thin, reflective sheets that harness the pressure of sunlight, or nuclear propulsion systems capable of generating immense acceleration. Though technically difficult, such designs suggest it may be possible to reach an interstellar object within a human lifetime. Others dream of pre-positioning a fleet of spacecraft in the outer solar system, like sentinels waiting in the dark. With enough readiness, one could be redirected to meet a visitor on short notice. There's even speculation about building long-term cosmic harpoons, spacecraft with the sole purpose of grabbing samples from passing objects before flinging them back toward Earth for study. These missions may sound futuristic, but they're not science fiction. The technology is within reach and the motivation is strong. Every interstellar visitor is a once-in-a-lifetime opportunity, unless, of course, we prepare well enough to make once-in-a-lifetime into once every few years. And why does this matter so much? Because holding a fragment of another star system in our hands would be like opening a book written in an alien language, a book that tells us how worlds are born elsewhere, and perhaps whether the seeds of life are scattered far and wide across the galaxy. The pursuit of these wanderers is more than just science. It is an act of curiosity, of daring, and of connection. To chase them is to acknowledge that our solar system is not isolated, but part of a greater galactic story. Part 7. Seeds of Life Among the Stars. Every time an interstellar object drifts through our solar system, a profound question lingers. Could these wanderers be carrying the very ingredients of life? For billions of years, comets and asteroids have bombarded Earth, delivering water, carbon compounds, and amino acids, the molecular building blocks from which life eventually emerged. If these raw materials exist in abundance here, might they not also be scattered throughout the galaxy, riding on fragments flung from other stars? This idea is not new. In fact, it has a name: panspermia. The theory suggests that life, or at least its chemical precursors, might spread between star systems on drifting cosmic debris. While it remains controversial, panspermia has gained renewed interest in light of discoveries like Oumuamua and Comet Borisov. If fragments from distant systems are constantly crossing paths with ours, then the galaxy could be far more interconnected than we ever imagined. Consider this: Borisov's chemical makeup, rich in carbon-based molecules, mirrors the kinds of substances we associate with life's origins. It means that the chemistry which shaped Earth is not unique. If interstellar comets are common, then the galaxy may be littered with starter kits for biology, waiting for the right conditions to spark something more. Some scientists even speculate that microscopic organisms, shielded deep inside rocky fragments, could survive the long journey through interstellar space. The distances are enormous and the radiation harsh, but certain extremophiles on Earth have shown resilience that defies expectation. If life can endure in the most brutal corners of our planet, who is to say it could not hitch a ride across the stars? Even if no living passengers ever make such a journey, the delivery of organic molecules could still change everything. Each interstellar visitor we study might hold chemical fingerprints from another stellar nursery, another world where prebiotic chemistry unfolded in parallel with our own. By studying them, we aren't just learning about rocks, we're exploring the possibilities of cosmic kinship, of shared origins that stretch across the Milky Way. And then there's the most daring thought of all. What if some interstellar objects are not random wanderers, but intentional messengers? A craft, a probe, or even a beacon sent deliberately across the gulf of space. While the majority of scientists lean toward natural explanations, the lingering what if keeps our imagination alive. After all, to wonder about life elsewhere is deeply human, and every anomaly in the sky is an invitation to dream. Part 8. Reflections of our future. When we look at interstellar wanderers, we are not only peering into the past of distant star systems, we are also glimpsing what might one day be our own legacy. Just as Oumuamua and Borisov drifted into our solar system, fragments of our world may someday travel outward, carrying whispers of Earth into the galaxy. In fact, it's already happening. Every rocket stage, every probe sent beyond the planets, every satellite that escapes the sun's pull, they all become part of a faint trail of human-made objects stretching into the void. Voyager 1 and Voyager 2, launched in the late 1970s, are already beyond the reach of our sun's influence. Each carries a golden record, etched with music, images, and greetings in many languages, a message in a bottle, cast into the cosmic ocean. From a distant star, billions of years from now, they might appear much like Oumuamua did to us, a mysterious, fast-moving fragment on a strange trajectory. Perhaps another civilization will wonder if these relics are natural or artificial, and debate their origins as we did. This perspective is humbling. Interstellar objects remind us that the galaxy is not a static place. Systems exchange material constantly, through violent collisions, gravitational slingshots, and ejections. Over cosmic timescales, the boundaries between stars blur. Just as Earth may receive fragments from other worlds, so too will pieces of our solar system drift outward, scattering into the Milky Way. And one day, it may not just be fragments. If humanity endures, we may become interstellar travelers ourselves. The same questions we ask of Oumuamua, where it came from, what secrets it carries, might one day be asked of ships bearing our descendants. To send explorers across the stars would be to complete the cycle, no longer waiting for visitors, but becoming them. In this way, studying these wanderers is more than science. It is preparation. It forces us to think about survival, communication, and the stories we want to send into the dark. It asks us to imagine how others might perceive us, and whether we too will one day be a fleeting glimmer in another sky. The interstellar messengers that pass through our solar system are not just relics of other worlds, they are mirrors reflecting our own destiny. Part 9. Redefining our place in the cosmos. For most of human history, the night sky seemed eternal and unchanging. Stars burned steadily, planets wandered predictably, and Earth appeared to be the fixed stage on which the universe revolved. But the discovery of interstellar visitors shattered that illusion, reminding us that the galaxy is alive with motion, chaos, and exchange. Oumuamua and Borisov showed us that our solar system is not isolated. It is part of a vast network of star systems, all bound together in the Milky Way's spiral arms. Materials do not stay confined to where they are born. They are tossed outward, pulled inward, and shared across unimaginable distances. Our sun, our planets, even the atoms in our bodies may once have been part of other stars, scattered and recycled in an endless galactic cycle. This realization is both humbling and exhilarating. On the one hand, it makes Earth seem small, just one planet orbiting one star, briefly illuminated by the passage of wanderers from beyond. On the other hand, it connects us to something far greater. If the same chemistry is happening across the galaxy, if fragments of countless worlds are mingling here, then Earth is not an isolated experiment. We are part of a cosmic story, one chapter in a book being written across billions of worlds. Interstellar objects remind us that the unknown is never far away. They slip into our skies without warning, forcing us to confront mysteries we didn't know existed. And in doing so, they expand our perspective. No longer can we think of our solar system as a closed box. Instead, it is a crossroad, a place where galactic travelers pass through on their endless journeys. This shift in thinking may be one of the greatest gifts of discoveries like Oumuamua. It forces us to see Earth not as the center of the story, but as part of a living, breathing galaxy. A galaxy where matter, chemistry, and perhaps even life itself are constantly shared and exchanged. In this way, each fleeting visitor is more than a curiosity. It is a reminder that the universe is dynamic, interconnected, and full of possibilities. And it challenges us to ask, what other surprises are waiting in the darkness, just beyond the reach of our telescopes? Part 10. The Endless Mystery. Every ending in science is only a doorway to a new beginning. Oumuamua and Borisov were not just strange visitors, they were messengers, whispering that the universe is far wilder and richer than we ever imagined. They arrived without invitation, lingered for only a short time, and vanished back into the cosmic sea, leaving us with more questions than answers. But perhaps that is their greatest gift, mystery. Humanity thrives on curiosity, and without puzzles, there would be no progress. The strange acceleration of Oumuamua, the pristine ices of Borisov, these are not just oddities, they are sparks that ignite imagination, driving us to look harder, think deeper, and explore further. What if other objects are already on their way, invisible in the darkness? What if the galaxy is filled with countless wanderers carrying not just dust and rock, but the raw ingredients of life? And what if one day we detect something that cannot be explained by physics alone, something crafted, deliberate, artificial? The truth is, we are only at the very beginning of this journey. The next century will bring telescopes sharper than ever, spacecraft capable of intercepting visitors, and perhaps, one day, the first sample return from beyond our solar system. Each discovery will remind us of one simple fact: the universe is not silent, it speaks through light, motion, and fleeting travelers. We only need to listen. And so the story does not end here. The cosmos is alive, restless, and full of secrets waiting to be uncovered. Each interstellar visitor is not the conclusion of a chapter, but the beginning of another. Because in the vastness of space, the most extraordinary truth may be this: we are not alone in our journey. We are part of an endless story written among the stars.
Part 1. The Stars Above the Desert. What if the night sky you see above you tonight is not just a view of stars, but a time machine into the past? The desert was quiet, wrapped in a velvet darkness that stretched endlessly to the horizon. Only the cool breath of night moved through the air, carrying the scent of dry earth and distant sage. Above, the sky unfolded in its full glory. Thousands upon thousands of stars, glittering like shards of ice scattered across black silk. For those who looked up, it was more than just beauty. It was history, written in light. Every star that shimmered overhead was telling a story from long ago. The light of Sirius, the brightest jewel in the sky, had left its star nearly 9 years earlier, crossing the void of space to reach this desert night. Farther still, the light of Betelgeuse, glowing faintly red in Orion's shoulder, had begun its journey more than 600 years ago, back when castles still stood across Europe and sails first touched distant oceans. To gaze at the stars was to gaze backward in time. Somewhere on the rocky ledge, an old telescope rested, its metal cool beneath the moonlight. Through its lens, the vastness became intimate. Galaxies revealed themselves as smudges of pale light, millions of light years away. Each one held billions of suns, billions of worlds, perhaps billions of unknown stories. The human mind could barely grasp it, yet it felt comforting somehow, like knowing you were part of something infinite. Astronomers often say that the universe is both impossibly huge and impossibly close. The atoms in our bodies, the very iron in our blood, were once forged in the heart of ancient stars that died long before Earth was born. To look at the Milky Way arcing across the desert sky was to look at family, distant, scattered, but kin nonetheless. A quiet breeze passed, and the desert seemed to listen. One could almost imagine the whisper of galaxies themselves speaking across time. We were here before you, and we will be here long after, but for this moment, we are together. And in that silence, something profound settled in. The night sky was not an empty canvas. It was alive with memory, with echoes of beginnings, with a promise that the story of the universe was still unfolding, and humanity had only just begun to read the first lines.
Part 2. The First Steps into the Sky. Long before rockets or satellites, long before electricity or machines, people were already reaching for the stars, not with hands, but with eyes and imagination. Thousands of years ago, humans stood under skies just as dark and wide as the desert night. With no city lights, the heavens were brilliant, so filled with stars that the Milky Way stretched across the horizon like a glowing river. Ancient people did not just see dots of light, they saw stories, gods, and maps. On the plains of Mesopotamia, Babylonian astronomers carved star patterns onto clay tablets, tracking the rhythms of Venus and Jupiter. In Egypt, the rise of Sirius marked the flooding of the Nile, a moment that gave life to the land. Across the ocean, the Maya built entire temples aligned with the sun and stars so that on certain days, light would pour into sacred chambers like a message from the heavens. And in the frozen north, the Vikings steered their ships by the pole star, trusting it as a steady guide in the endless sea. All around the world, people looked up and asked the same question: what lies beyond? Centuries passed, and answers began to change. The Greeks imagined celestial spheres. Ptolemy described a universe with Earth at its heart. For over 1,000 years, that picture stood unshaken. But then, slowly, voices rose that dared to imagine differently. In 1543, Nicholas Copernicus whispered a radical thought. Perhaps the sun, not Earth, sat at the center. Later, Galileo Galilei turned his telescope skyward and saw mountains on the moon, moons orbiting Jupiter, and the faint light of countless stars inside the Milky Way. He realized the universe was far richer than anyone had dreamed. The centuries rolled on, and every discovery pulled humanity's gaze farther outward. Newton explained gravity, the invisible hand that tethered apples to Earth and planets to the sun. Herschel revealed Uranus, a planet no eye had noticed before. And in the 20th century, Edwin Hubble showed that even the faint smudges in the night sky were galaxies, entire universes of their own. Yet the longing remained. People wanted not only to look, but to go. The first rockets were crude, born from fire and war, but they carried a promise. One day, humanity would ride them beyond the cradle of Earth. In 1961, Yuri Gagarin became the first to leave our planet, circling Earth in a fragile capsule. His voice calm as he said, "I see Earth. It is so beautiful." That moment changed everything. For the first time, humanity had truly stepped into the sky. From ancient stargazers to astronauts, the story of reaching for the stars was no longer just myth or dream. It was reality, unfolding before human eyes. And as Earth spun beneath, blue and delicate against the black, one truth became clear. The universe was vast, but the journey had only just begun.
Part 3. The Race to the Moon. The night sky had always been filled with mysteries, but now, for the first time in history, people weren't just staring at the moon, they were preparing to go there. The 1960s unfolded like a drama written among the stars. The world's two great powers, the United States and the Soviet Union, were locked in a silent duel, a competition not just of technology, but of imagination. Who would prove first that humanity belonged beyond Earth? The Soviets struck first. Sputnik, the tiny beeping satellite, circled our planet in 1957, shocking the world. Soon after, Yuri Gagarin's smiling face became a symbol of possibility as he looked at Earth from orbit. The Americans, stunned but determined, set their eyes on something even greater, sending a human to the moon. In 1961, U.S. President John F. Kennedy spoke words that carried the weight of an impossible dream. "We choose to go to the moon." At that moment, the destination shifted from fantasy to a promise. The years that followed were a blur of triumphs and disasters. Rockets exploded, astronauts risked their lives, engineers worked through sleepless nights. Each Apollo mission brought humanity a step closer, first orbiting Earth, then testing the spacecraft in deeper space, until finally, Apollo 11 was ready. On July 16, 1969, the Saturn V rocket, taller than a 35-story building and powerful enough to shake the ground for miles, thundered into the sky. On board were three men, Neil Armstrong, Buzz Aldrin, and Michael Collins. For 4 days, they sailed through the void, their tiny capsule a fragile speck between Earth and Moon. Then came the moment. The lunar module, named Eagle, separated from the command ship. With Armstrong and Aldrin inside, it descended toward the Sea of Tranquility. The world held its breath as Armstrong's calm voice crackled through the radio. "Houston, Tranquility Base here. The Eagle has landed." Hours later, Armstrong climbed down the ladder, his boot hovering just above the alien soil. He pressed down, leaving a print that would remain for thousands of years. His words, broadcast to millions on Earth, were simple and eternal. That's one small step for man, one giant leap for mankind. Buzz Aldrin followed, describing the moon's surface as magnificent desolation. Together they planted a flag, set up experiments, and wandered in wonder. Michael Collins, circling above in the command module, later wrote that he felt both isolated and deeply connected, the only human truly alone, yet carrying the hopes of all humanity. When the astronauts returned, the world was never the same. Children looked at the moon and knew humans had been there. The night sky was no longer untouchable. It was a destination. The moon landing was not just a victory in a race. It was proof of what humanity could achieve when driven by curiosity, courage, and unity. For a moment, the divisions of Earth seemed small compared to the footprints in lunar dust. And as Armstrong, Aldrin, and Collins sailed back home, Earth rose before them, fragile, blue, and glowing against the infinite black. They had traveled 240,000 miles away, yet they discovered something profound. The most beautiful place in the universe was still their home. Part 4. Homes Among the Stars. If landing on the moon was humanity's first great leap, then learning to stay in space was its first lesson in patience. After Apollo 11, the world was awash with wonder. Yet after a handful of missions, the moon began to feel less like a dream and more like a conquered milestone. Governments shifted focus, budgets tightened, and a new question rose. Instead of only visiting space, could we learn to live there? The Soviets moved first again, launching Salyut-1 in 1971, the first space station. It was small, no larger than a bus, but to the cosmonauts who entered it, it felt like a new frontier. They floated through its narrow halls, working, sleeping, and eating, while Earth drifted silently beneath them. For the first time, humans weren't just astronauts, they were space dwellers. The United States answered with a marvel of its own, Skylab, launched in 1973. It was bigger, brighter, and allowed crews to stay in orbit for weeks. From Skylab's windows, astronauts filmed sun flares and gazed at continents stretching endlessly below. They even held the first space shower, experimenting on how to stay clean when water refused to fall. But humanity's true long-term home in orbit would not come until decades later, when rival nations set aside their race and began building together. The result was the International Space Station, ISS, a vast city of metal modules and solar panels that still orbits Earth today. Construction began in 1998. Piece by piece, carried by rockets and the space shuttle, the ISS grew like a puzzle assembled in the sky. Astronauts from across the globe, Americans, Russians, Europeans, Japanese, Canadians, all brought their cultures, their languages, and their dreams. Life aboard the ISS was unlike anything ever imagined. Astronauts slept in small cabins, zipped into sleeping bags that floated against the walls. Meals came in packets that had to be hydrated before eating, and even drinking water required a straw so it wouldn't drift away in globules. Every day was carefully planned. Hours of scientific experiments, maintenance, exercise, and communication with Earth. And yet, beyond the routine, there were moments of pure wonder. Astronauts watched 16 sunrises and 16 sunsets each day as the station circled the planet. They marveled at the glowing bands of the aurora dancing below. Sometimes, during quiet nights, they pressed their foreheads to the window, staring at Earth as a glowing jewel floating in darkness, feeling both infinitely small and unimaginably lucky. The ISS became more than just a laboratory. It was a symbol. For centuries, nations had fought over borders on a single planet. But here, hundreds of kilometers above Earth, people learned to cooperate, to share oxygen, water, and trust. When astronauts returned to Earth, many spoke of the overview effect, a shift in perspective from seeing our world whole without lines or borders, fragile and united. One Russian cosmonaut described it best. When you first look out the window and see Earth, you suddenly realize we are all family. The moon had been about conquering distance. The space stations were about conquering time. They taught us how to endure in the void, how to breathe, work, and dream in microgravity. They taught us that space was not just a place to visit, it could be a home. And as the ISS continued circling, the question that had burned since the Apollo days returned with even greater force. If we could live in orbit, what about Mars? Part 5. Shuttles and Rovers and the Call of Mars. If space stations were about learning how to stay, the space shuttle was about learning how to return again and again. In 1981, the world watched in awe as Columbia roared into the sky, not on the tip of a rocket, but on wings, with the promise of flying back like an airplane. The space shuttle program had begun, and with it, a new chapter in exploration. For 3 decades, the shuttle fleet, Columbia, Challenger, Discovery, Atlantis, and Endeavour, carried astronauts into orbit, ferried modules to build the International Space Station, and deployed satellites like the Hubble Space Telescope. Unlike Apollo, this was not a one-way ticket. The shuttle could land on a runway, roll to a stop, and be prepared for its next flight. The shuttle symbolized routine access to space, but it also carried deep risks. The tragedies of Challenger in 1986 and Columbia in 2003 reminded the world that spaceflight was never ordinary, never safe. Each loss was a painful scar, brave crews giving their lives in pursuit of something larger than themselves. Yet even through grief, the missions continued. While humans orbited Earth, robotic explorers became our eyes and hands across the solar system. In 1997, Sojourner, a small 6-wheeled rover, landed on Mars with NASA's Pathfinder mission. It was no larger than a microwave, but it showed the world that Mars could be touched, studied, and explored by our machines. The images it sent back were surreal. Orange-red landscapes under a salmon sky, rocks shaped by ancient winds, a world frozen in silence. Then came the Mars rover's Spirit and Opportunity in 2004. Designed to last only 90 days, Opportunity rolled on for an astonishing 15 years, driving across craters, dunes, and plains, whispering secrets of a planet that may have once held rivers and lakes. When its final signal faded in 2018 after a global dust storm, NASA scientists said goodbye with words that moved the world. "My battery is low, and it's getting dark." And above Earth, the Hubble Space Telescope, launched in 1990, gave humanity its clearest view yet of the cosmos. Through Hubble's lens, we saw galaxies colliding, stars being born in glowing nebula, and light from the edge of the universe, billions of years old, finally reaching us. Some scientists wept at the images, feeling for the first time that they were truly looking into eternity. But beyond telescopes and rovers, the dream of Mars began to grow stronger. If humans could live in orbit, could they also walk on the red planet? Engineers, scientists, and dreamers debated everything: how to survive the radiation, how to grow food, and how to return safely. The shuttle retired in 2011, but it left behind the International Space Station and a new generation of private space companies determined to carry the torch further. Space was no longer the domain of governments alone. It was becoming a new frontier for humanity as a whole. Through every success and setback, one idea kept echoing. Earth is our cradle, but not our cage. The rovers had shown us the path. The telescopes had shown us the stars. And the next step, the boldest of all, was clear. The next great journey would not stop at orbit. It would not stop at the moon. It would point directly to Mars.
Part 6. A New Dawn. Private Spaceflight in the Artemis Generation. For the first time in history, space was no longer just about nations. It was about people, companies, and the shared dream of an entire species. After the Space Shuttle retired in 2011, NASA relied on Russian Soyuz spacecraft to carry astronauts to the International Space Station. It was a strange pause. The United States, once the leader of human spaceflight, had no vehicle of its own to reach orbit. But in the silence of that gap, something unexpected began. A new era of private space exploration. One company, SpaceX, founded by Elon Musk, had a vision that seemed more like science fiction than engineering. Reusable rockets that could land themselves. Spaceships that could carry people to the moon, to Mars, even to other worlds. At first, many laughed. Rockets had always fallen into the sea, destroyed in fire and waves. Landing them seemed impossible. But on a December night in 2015, the world watched as a Falcon 9 rocket descended from the sky and touched down upright, its engines glowing against the darkness. It stood tall, balanced as though it had never left. The impossible was now real. From that moment, the future of spaceflight shifted. SpaceX began flying cargo and then astronauts to the ISS. Other companies, Blue Origin, Rocket Lab, Virgin Galactic, joined the race, each with its own bold vision. What once took governments decades and billions of dollars, private innovators were now doing it faster, cheaper, and with breathtaking ambition. Meanwhile, NASA turned its gaze back to the moon. The Artemis program, named after Apollo's twin sister, was announced with a promise: to land the first woman and the first person of color on the lunar surface, and to use the moon as a stepping stone to Mars. Artemis wasn't just about visiting. It was about building a sustainable presence, with habitats, vehicles, and a space station orbiting the moon called Gateway. In 2022, Artemis 1 launched, the most powerful rocket since Saturn V, called the Space Launch System, SLS. It carried the Orion spacecraft on a journey around the moon, uncrewed but blazing a trail for the missions to come. When it returned safely to Earth, it felt like the drumbeat of a new age. But perhaps the most stunning vision of all came not from rockets, but from light. In July 2022, humanity unveiled the first images from the James Webb Space Telescope. Where Hubble had shown us galaxies colliding, Webb showed us the earliest galaxies ever born, glowing faintly at the dawn of time. It looked back over 13 billion years, almost to the moment when the first stars flickered into being. Scientists stared at the images in silence. Some cried, others laughed with disbelief. It was as if the universe itself had opened a curtain and invited us to witness its secrets. And still, the dream of Mars burns brighter. SpaceX's Starship, the largest rocket ever built, is designed to carry hundreds of people at once. Its stainless steel body gleams in the sunlight like something pulled from a retro sci-fi film. Test flights explode, crash, and fail, yet each time they rise again, improving, moving closer to the day when one will succeed. For the first time since Apollo, children grow up not just hearing stories about space, but seeing rockets land, telescopes unveil cosmic mysteries, and missions preparing to go farther than ever before. The new dawn has arrived. Humanity no longer asks, will we go back, but rather, how far can we go? And the answer, whispered in every launch, every rover, every telescope, is simple. As far as our dreams will take us.
Part 7. The Future, Mars, Beyond, and the Question of Life. Every age of exploration has its frontier. For the 21st century, the frontier is not across oceans or deserts. It is across the infinite sea of stars. For decades, Mars has been more than a planet. It has been a symbol of hope, of challenge, of destiny. At night, it glows red in the sky, a reminder that another world circles close, waiting. Scientists know its secrets are buried in the dust, dried riverbeds, frozen glaciers, maybe even the remnants of ancient life. Rovers like Curiosity and Perseverance have already begun uncovering that story. Perseverance, still rolling across Jezero Crater, carries a microphone that lets us hear the whisper of Martian wind. It collects samples of rock, sealing them in tiny tubes, waiting for the day a future mission returns them to Earth. If those rocks reveal signs of microbes, even long dead, it will mean that life is not unique to our world, that it can arise wherever conditions allow. And if it happened twice in one solar system, how many times across billions of galaxies? Mars is also the target for human footsteps. NASA, SpaceX, and other agencies talk about the 2030s. It will not be easy. The journey takes months. The environment is harsh. The dangers immense. But every great leap in history has been filled with risk. The first settlers may live inside caves or in pressurized habitats, growing food under glass domes, relying on Earth but dreaming of independence. Someday, children may be born on Mars, their first sight of the sky a salmon-colored horizon beneath two tiny moons. Beyond Mars lies the outer solar system with its icy treasures. Moons like Europa and Enceladus hide oceans beneath their frozen shells, oceans larger than all the water on Earth combined. Plumes of water shoot into space, hinting at hydrothermal vents, warmth, chemistry. Could life exist there, swimming in alien seas under starlight that never touches the surface? NASA's Europa Clipper and future missions may soon bring answers. Asteroids, too, beckon. They are not just rocks, but resources, metals, water, the building blocks of industries that could fuel colonies and spacecraft. Mining them sounds like science fiction, but private companies already design concepts for it. One day, whole economies could stretch into space. And then, the greatest question of all, the stars. For now, they are impossibly far. The nearest, Proxima Centauri, is 4.24 light-years away, a distance so vast that even our fastest spacecraft would take tens of thousands of years to reach it. But humanity does not stop at impossible. Projects like Breakthrough Starshot imagine sending tiny, laser-powered probes to another star within a single human lifetime. They would fly faster than anything built before, carrying cameras and sensors the size of a chip, sending back images of alien worlds orbiting suns we can barely see with the naked eye. And above it all hangs the question, are we alone? Radio telescopes listen for signals. Scientists scan exoplanets for atmospheres rich with oxygen, methane, or strange chemicals that could only be made by living creatures. We have found thousands of planets already, some rocky, some with oceans, some orbiting in the habitable zone. Statistically, it seems impossible that Earth is the only world with life. But until the day we hear a signal, or find a fossil, or see a cell swimming under a microscope from another world, we do not know. Perhaps the universe is full of civilizations separated by distance and time. Perhaps we are the first, the pioneers, destined to carry the spark of consciousness outward into the stars. What is certain is this: the story of space is only at its beginning. Our ancestors looked at the sky with fear and wonder. We look at it with curiosity and courage. Someday our descendants may look at it from new worlds, from cities on Mars, from ships sailing between the stars. And when they do, they will remember that it began here with a species on a small blue planet daring to dream.
Part 8. The Endless Sky. At night, when the world falls quiet, the sky opens like a book. Each star a page, each galaxy a chapter, and we are only beginning to read. Space has always been both infinite and intimate. Infinite in its distances, its mysteries, its ancient light that has traveled for millions of years before touching our eyes, and intimate in the way it whispers to us, in the way a child points to a constellation and feels connected to something greater. From the first fires our ancestors lit under dark skies, to the telescopes that pierce the veil of time itself, humanity's gaze has never left the stars. We have always been a species of dreamers, carried forward by wonder. We now know the universe is vast beyond comprehension. Trillions of stars, trillions of worlds, perhaps countless civilizations, or perhaps only silence. Both possibilities are equally profound. If we are alone, then we carry a responsibility to cherish life, to protect it, and to let it bloom among the stars. If we are not, then one day, across the gulf of light years, we may learn we are part of a grander story than we ever imagined. The future is unwritten, but the direction is clear. Mars glows on the horizon, beckoning us forward. Oceans under icy moons call to us with the possibility of strange new life. Distant exoplanets tempt us with the dream of stepping onto worlds that circle suns we have only just discovered. And above all, the stars remain, patient and eternal, waiting for us. In the quiet of night, when we close our eyes, it is comforting to know that the universe is not empty space, but a living sea of possibility. Every star is a lighthouse, every nebula a cradle, every orbit a dance. We may never see all of it. We may never hold the answers to every question, but we are part of this vastness, stitched into the same fabric of space and time. Our atoms were born in stars that lived and died long before Earth existed. To look at the night sky is to look at our origin, and perhaps also our destiny. So tonight, as sleep drifts closer, imagine the journey still ahead. Ships sailing past Saturn's rings, footsteps echoing on Martian soil, explorers diving into the oceans of Europa, signals whispering from far-off civilizations. Imagine generations yet to come, gazing at new skies, telling new stories, always guided by the same wonder that lives in us now.
Epilogue: A quiet universe. Sometimes the most profound discoveries are not made in the roar of rockets, but in the silence between heartbeats under the stars. There is a kind of peace in knowing that the universe is not in a hurry. Stars live for billions of years. Galaxies drift slowly, colliding in dances that last longer than all of human history. Compared to that, our lives are brief, but they are no less meaningful. Every time a child makes a wish on a falling star, or an astronomer peers through a telescope, the universe takes on a human shape. Our curiosity, our need to connect, our longing to understand, these are the qualities that turn an infinite expanse of stars into a home. Astronauts often describe something called the overview effect, the shift in perspective when they see Earth from orbit. From space, there are no borders, no divisions, only a fragile blue world floating in darkness. They return changed, gentler, more aware of how precious life is. Perhaps, in a way, that is the purpose of looking outward, to remind us to care for what we have here, to see ourselves not as separate nations, but as travelers sharing one vessel, circling one star, journeying together. And when the night deepens and the stars emerge, it is easy to imagine that someone, somewhere, is looking back, a traveler on a distant world, perhaps, gazing up and wondering if they are alone. Perhaps their eyes fall upon our sun, just another star in their sky, and they wonder what lives might be circling it. The universe is vast, but it is also intimate. It touches us in ways both grand and quiet. In the glow of Saturn's rings, in the silence of lunar dust, in the shimmer of auroras dancing across polar skies, and in the way your heart slows as you drift into sleep, comforted by the thought of endless possibility. So, rest now. Imagine yourself weightless, floating among galaxies. Let starlight guide your dreams. And remember, the universe is not something far away. It is already inside you. Sleep well, explorer. Tomorrow, the journey continues.